Let's get started. Here we are in Chapter 1, and your text starts out with a discussion of electronic systems. And the first thing that it addresses is talking about, well, what is an electronic system? And it has a brief definition. It says, a label describing a group of devices controlled by a number of interconnected electronic components. And so here we have a concept here of devices that are controlled by, notice, electronic components. And when we talk about these components, this is a large part of the subject of this particular course. We're talking about things like resistors and transistors and capacitors and MOSFETs and operational amplifiers and just a wide range of electronic components. Now, the second item mentioned here is the complexity of these components. They can range from 2 to 3 components to literally many millions. And when we get into the lab portions of this course, we're going to start out with some real basic stuff. We'll probably have a little power supply, and we will connect in some basic components, and we will have some real simple circuits. But even though electronic systems start at a very simple level, they can become very complex. And over here we see a system board, and system boards represent literally millions of components. Regardless of complexity, all electronic systems are composed of a few basic types of components with well-defined behavior. And understanding the behavior of these fundamental electronic components will allow you to analyze, understand, and troubleshoot all electronic systems. Now, it's hardly the purpose of this course to train you to troubleshoot all electronic systems. But the underlying idea here is that if you understand the basic behavior of components, which are the building blocks of all electronic systems, you'll have at least some degree of a sense of how do these systems actually work. Your text mentions 5 representative electronic systems. I suppose there are literally hundreds, if not thousands, of systems that could be addressed, but it mentions 5. So let's just take a brief look at 5 electronic systems. First one is television, and electronic signals from cable or antenna allow for viewing of television programming. That's what television is, what a television system is. Televisions are built from electronic components, and these are the same components that we mentioned earlier. Though not mentioned in your text, the television was actually invented in 1927. An individual named Philo Farnsworth, actually a teenager, invented the TV. And in those days, I remember the TV, it was just kind of an oval shape, and it had an image on it which wasn't very clear, but it was the beginning of video. In the 90s, we had the advent of HD TV, which was a far cry from that first TV that Philo Farnsworth came up with in 1927. But the interesting thing about it is that the components that are used in that 1927 television, a few of those same components are still going to be in that HD TV in the 1990s, though it's a much more sophisticated and complex device. Some of the components still remain the same. The next representative system we'll look at are computers. And again, as we mentioned here, we have a computer system board, and the complexity there is quite advanced. And again, they are built out of electronic components. And computers, what do computers do? Well, they accept inputs from a variety of sources to include mice, keyboards, switches, human voice, network, etc. They allow for computations, production of a wide variety of outputs, and manipulation of data. But again, they are built from electronic components. Industrial robots. Now here is our friendly robot walking along. These, what is a robot? Well, these electromechanical systems provide a wide variety of functions. Interesting to note here that a robot is electronic and it is also mechanical. It's a merging of two technologies. And robots have just, their use is expanding daily. They have begun to be used quite a lot in medical applications, and you might not think, well, how can a robot be used in medical? Well, some of the newest applications have been to use robots in performing surgical procedures, and so there's still a human that controls the robot, but the actual cutting is done by the very steady movement of a mechanical arm from the robot. It is also very interesting. We have a biomed program at North Seattle Community College, and we teach students, they do the basic electronics training, but then they do a lot of also study in the medical area, and they do some specialized training in repairing medical systems. And it's one of the highest employment areas where we are able to place students. And so many of our students are working in the arena of repairing medical electronic systems. They have lots of industrial applications as well. I'm thinking of just one student a few years back who went to work for the Seattle Times, and over at the Times his job was to maintain the 5 robots they use that move the paper from the storage area over to the large printing presses. So that particular task is assumed by a robot, but someone has to maintain the robot, and so his job was to maintain the robots there at the Seattle Times. And many menial tasks are being taken over by robots as well. Things like, vacuuming the rug, cutting the grass, things like this are tasks that we're beginning to see robots taking over. Robotics are very popular in Seattle. There's a large robotics club in Seattle for any of you that may be interested in this area. They have competitions, and lots of hobbyists participate in this, and it's a lot of fun. Avionics, another representative system of electronics. Actually, the name avionics stands for aviation electronics, and so a wide or a large area of electronics is specifically devoted to the area of aviation, and the demands for on electronic systems and aircraft are really quite extreme. If you think about an aircraft when it takes off and it starts out at a low elevation and quickly can be at 30 or 40,000 feet, and all of the pressures that come to bear on those systems, from the changes in barometric pressure, the changes in temperature, humidity, all of those things are changing constantly on these systems, and yet these systems have to continue to operate in a stable manner. And so the challenges on electronic systems and aircraft are quite high. Here is a picture. In this picture here, we see an aircraft carrier, and notice that what's the purpose? Well, they support aircraft. I spent several years actually working on board an aircraft carrier, maintaining the electronic systems in aircraft. In aviation, let's see, these are complex systems integrating navigational, flight control, communications, weapons control, and weapons control for military aircraft. And again, avionics systems are all built from the common building blocks, which was the theme that we started with. Then the internet, and here we have 2 computers talking to each other, and you see the globe in the background giving the idea, well, this is a worldwide thing of interconnectivity. And the internet, by definition, is an interconnection of many subsystems utilizing computers, routers, hubs, switches, and millions of miles of cable. And I'll just point out here that computers, routers, hubs, switches, these are all examples of electronic systems. So, we've been talking about building blocks. The common theme of all these systems is that they share the same electronic building blocks or components, which are the subject of this course. And so, as we proceed in this course, we're going to be spending a great deal of time looking at the behavior of specific components. How do they actually work, and how do they interact within these systems?